So our examples are going to look at functions as power series. The first example is 1 over 1 plus x. Recall the geometric series is a over 1 minus r, so we're going to transform into 1 over 1 minus negative x. This expands out into 1 plus negative x squared plus negative x cubed onto negative x to the n. So that's the summation from n is equal to 0 to infinity of negative x to the n. So the function 1 over 1 plus x is the summation from n is equal to 0 to infinity of negative 1 to the n times x to the n. And then to get the interval of convergence, that's the absolute value of the ratio is less than 1. That will make the series converge. So we take the ratio, which was negative x, absolute value is less than 1. To simplify that, that makes the absolute value of x is less than 1. And so x is between 1 and negative 1. And so the interval of convergence is negative 1 to 1. The next example, the function is 1 over 1 plus x squared. So to rewrite that into the form, we have 1 over 1 minus negative x squared. Expanding that out as 1 plus negative x squared squared onto negative x squared to the nth power. So that's the summation from n is equal to 0 of infinity of negative x squared to the nth power, which is a summation from n is equal to 0 to infinity of negative 1 to the n, x squared to the n. So that's the summation of n is equal to 0 to infinity of negative 1 to the n, x to the 2n. So 1 over 1 plus x squared is that summation, that series. The interval of convergence is the absolute value of the ratio less than 1. The ratio is negative x squared, which is the absolute value of x squared, which when you square root, the absolute value of x is less than 1, so the interval of convergence is from negative 1 to 1. The next example, we'll look at 1 over 5 plus x. So that's dividing by 5 to get into the form of a over 1 minus r. We have 1/5 over 1 minus negative x over 5. So expanding that out as the power series, we have 1/5 plus 1/5 negative x over 5 plus 1/5 negative x over 5 squared onto 1/5 times negative x over 5 to the nth power, which is the summation from n is equal to 0 to infinity of 1/5 times negative 1x over 5 to the n, which is the summation of n is equal to 0 to infinity of 1/5 negative x to the n over 5 to the n, which is the summation from n is equal to 0 to infinity of negative 1 to the n, x to the n, over 5 to the n plus 1. So 1 over 5 plus x is that series, or that summation. The interval of convergence is the absolute value of the ratio less than 1. The ratio in this problem is negative x over 5, which is looking at the absolute value of x over 5. So x over 5 is between negative 1 and 1. So x is between negative 5 and 5. The interval of convergence is negative 5 to 5. The last example, we're looking at x to the 5th over 7 minus 9x cubed. Dividing by 7 to get out of the form a over 1 minus an r. We have x to the 5th over 7, 1 minus 9, x to the 3rd over 7. So the a is x to the 5th over 7. First term is x to the 5th over 7 plus x to the 5th over 7, and the ratio is 9x to the 3rd over 7. So writing out our terms all the way until we get to x to the 5th over 7 times 9x to the 3rd over 7 to the nth power. So the summation from n is equal to 0 to infinity of x to the 5th over 7, 9x to the 3rd over 7 to the nth power, which is the summation of n is equal to 0 to infinity of x to the 5th times 9 to the n times x to the 3rd to the n over 7 times 7 to the n, which is the summation of n is equal to 0 to infinity of x to the 5 plus 3n times 9 to the n over 7 to the n plus 1. And so then that is x to the 5th over 7 minus 9x to the 3rd as a power series. The interval of convergence is the ratio, absolute value of the ratio less than 1. And the ratio in this problem was 9x to the 3rd over 7. So that's the absolute value of x to the third is less than 7/9 by multiplying by 7/9. So x to the third is between 7/9 and negative 7/9. Cube rooting, get x is between the cube root of 7/9 and negative 7/9. So the interval of convergence is the negative cube root of 7/9 to the cube root of 7/9.